Alright, so welcome back to the Study Guides channel. I apologize for uploading this one so late. I just had to cover the last topic to make sure I was sure with it. So welcome back. Today this one's going to be about geometric sequence mainly, but we'll also be focusing a bit on harmonic and the Fibonacci sequence. So let's get started. So first, let's illustrate and define a geometric sequence. So a geometric sequence is pretty similar to an arithmetic sequence, but it uses a common ratio r. Each term is multiplied by this r, and we are going to be using these important formulas later on. So basically, a geometric sequence is similar to an arithmetic, but it's constantly multiplied to a certain number. So let's take this, an example of a geometric sequence would be something like 1, 3, 9, 27, 81. So how do we solve for the common ratio? Well, it's very simple. Just like how we subtracted these two consecutive terms from each other to find the common difference in arithmetic, we are now going to divide these two terms by each other to find the ratio, common ratio. So we got 3 divided by 1 is just 3. 9 divided by 3 is also 3. 27 divided by 9 is also 3. So our r for this one is equal to 3. So that's basically how you find the formula and the common ratio. It's the fundamental basic you need to know. Next, but what differentiates the okay, we have illustrated that. Hold on. Here. All right, so we're done with that one. It's pretty quick. It's pretty self-explanatory. But how about the next one? What makes a geometric sequence geometric? Well, a geometric sequence uses a common ratio, while an arithmetic sequence uses a common difference. In geometric sequence, you're most likely going to divide and multiply, while in arithmetic sequence, you are most likely going to add or subtract. And geometric sequence intends to have these ridiculously high numbers. Like, even though the common difference might just be a single digit, you could be dealing with the millions easily. So that's why I call it this exponential increase. Meanwhile, arithmetic sequence is just a fixed increase. Like, it's not gonna rapidly rise. It's just gonna be an arithmetic increase that's fixed all throughout until your sequence reaches infinity. So this, you can screenshot this GS versus AS for free. It's fine. Just review it later on. So there you go. That's, in a nutshell, that's basically the difference between a geometric sequence from an arithmetic sequence. All right, here comes the main part of our discussion. All right, sorry for the sudden cut there. I was trying to figure this out, but yeah, recall. So basically, I've listed down the order of these terms, and by this analysis, we can confirm that 405r cubed is equal to 15. You might be wondering why. It's because once we multiplied r 3 times to get to 15. So this is just like saying 405 times r times r times r. You might be wondering why. Because this is r, this is another r, and this is another r. So this, every time you multiply by r, you're adding to this exponent here. So therefore, since we hopped 3 times and we multiplied r 3 times to get 15, therefore we can say 405r cubed is equal to 15. But once again, we're going to have to isolate r cubed. So we need to divide both sides by 405. And if you've learned from physics, this is basically just deriving once again. So dividing both sides by 405 means that this will be cancelled out, because 405 divided by 405 is just 1, and you don't need to write 1. So you can just put r cubed is equal to 15 over, what's this? 15 over 405. But once again, we don't want r cubed, we just want r. So put it in your calculator. If you can do fraction notation, that would be good. But if we can cube root both of this, let's see, 40. All right. So this simplifies to 1 over 27. But let's carry it over here. Since we want r, we're gonna have to cube root it. So cube root cube root 1 over 27. So put this in your calculator. Cube root of 1 over 27. So that should be equal to 0.33333 or 1 over 3. So r is equal to 1 over 3. So now that we have the r, we can just put in our calculator 405 times 1/3 to find our answer. So 405, or if you can't, if you don't support the fractions, you can just do divide by 3, because that's the same thing. 1/3 is the same as dividing by 3. So divide by 3, that's 405 times 1/3 is 135, and divide that by 3 again, it's 45. And to confirm that our answer is correct, 45 divided by 3, or 45 times 1 over 3, is once again 15, which means these are our two geometric means. Next one. Insert 3 geometric means between 243 and 48. So 243, blank, 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 48. Alright, so we're gonna do the same strategy once here again. So 243, we have how many of this? 1, 2, 3, 4. So we have 243 r raised to 4, because we hopped 4 times to get to 48, is equal to 48. Once again, we're gonna have to derive for this one. So we just divide both sides by 243. Why? Because we want to isolate r into one side. So 243 divided by 243 once again is just 1, and that can be omitted. So that's just r raised to 4 on this side. Meanwhile here, we got 48, and since we divide both sides by 243 to keep it equal, we have to put 243 over here. So 243, r raised to 4 is equal to 48 over 243. So what do we do now is, once again, we're going to take the fourth root. So let's simplify this fraction first. 48 divided by 243. We're going to simplify that is equal to, r raised to 4 is equal to 16 over 81. But that's not our answer yet, because we just want r. So taking the fourth root of that, so if you can, there's always a button for this, okay? You just need to go around and look your calculator and play a bit with it, and then you will get your answer. So after getting the fourth root of each, so let's write that down. So the fourth root of each one, you can get more than the cube root, by the way. Let's bring it all the way here, and that equals to r equals 2 over 3. And perfect, we now have the common ratio. Let's go multiply this by our first term, 243 times, alright, so that's going to be 162, and then 162 times 2 over 3, that's going to be 108. So, and then 108 times 2 over 3, that's going to be 72. And just to confirm, 72 times 2 over 3 is equal to 48. So those are 3 geometric means between 243 and 48. Alright, so we have determined the geometric means. So that is what we have so far. Next, find the nth term. So an nth term is this one once again. So we actually did something a bit more complex before we did nth term, but well, the competencies say in that order, and I'll go by that order. So let's recall our formula where a sub n is equal to a sub 1 times r raised to n minus 1. So yeah, it's a pretty complex formula, but let's do this. So, alright. The first term of a geometric sequence is -6, and the common ratio is 3. Find the 11th term. So first and foremost, let's start with a sub n. We want the a sub 11 because we want our 11th term. Next, we have our a sub 1. a sub 1, or the first term of the geometric sequence, is given to us, is negative 6. Next, we need a common ratio, which is also given to us. That's going to be in parentheses 3. Then, we want to find the 11th term, or our n, so that's 11 minus 1. So, negative 6 is going to be multiplied after we evaluate this. So, that's going to be 3 raised to 10 times negative 6. That's a sub 11 for you. And then, let's put that in our calculator. Negative 6 in parentheses 3 divided by 3 raised to 10 is equal to, a sub 11 is equal to, don't be surprised if you get a really high number, it's normal, but it should be negative 354,294. So let me just confirm if that's the correct answer. Okay, for some bizarre reason our presentation is broken, so I just verified it manually, and yes, this is the correct answer. Alright, next one. Determine the number of terms in the sequence 3, 9, 27, 6561. Now, I'll be real with you, okay? I was actually, okay, there's actually a pretty easy way to solve this. First and foremost, we want to find the, so since this is, it starts with 3, we can pretty easily determine that. So what you want to do is actually use a button called logarithm. So logarithm, basically, you can just simply type log, find the log button, 6561 divided by log 3, and that will give you the answer actually. So let's type it together. Log 6561 divided by log 3, that's equal to 8. So you might be wondering, what is log? Well, to put it simply, it tells the calculator, okay, how many 3's do I have to multiply to each other? So like, how many 3 times 3 times 3 and so on, until I get the number 6,561. And in this case, it's 8. So that actually tells us the answer, but let's just manually verify it. So we got 3, 9, 27, 81, 243, 729. Okay, this is where it gets a bit tricky. 729 times 3 is 2187, and 6561. So that is, yeah, that's 8 terms. But this only works if you if you know that the first term is also equal to the common ratio. So I'll show you the longer solution as well. Yeah, the really glitchy answer key is really pissing me off, but once again, this utilizes the a sub n formula. A sub n is equal to a sub 1 r raised to negative 1. So once again, we can rewrite this as 6,561 is equal to 3 times, what do you call this? 3 times, 3 times, ratio is 3. Yeah, 3 times 3 raised to n minus 1. But this can also be written as 6561 is equal to 3 raised to 1 times 3 raised to n minus 1. And since we're multiplying these exponents, 1 minus 1 is essentially 0. So this is 6561 is equal to 3 minus over n. And you can just, if you have the solve function, you can actually just directly solve this. But if you don't, you really have no other choice. But this is already a sufficient solution, so it's okay. You can just manually type it until you get the right answer, which in this case, once again, n is equal to 8. So as you could see, you can use either two of these and this will work. You can, for the general math, you can just explain the logarithms how I've explained it. And if you need any more explanation on why it works, I can give you the basics, although I haven't really quite discussed it. Okay, so that is, we have nth term of a geometric sequence. So that is also done. I'll take a short break and I will finish the rest of this as well. Alright, so I'm back. We're gonna continue. Now let's go find the sum of terms in a given finite or infinite sequence. So that's going to be these two right here. So first example, we're going to have to find the sum of the first 15 terms of the geometric sequence 4, 8, 16, dot, dot, dot. Alright, so this is example of a finite sequence, as finite means there's a limited the amount of terms. In this case, it's 15. Or in this case, first 15. It could go on for forever. So we're going to have to use the sum of the finite geometric sequence, which is here. So that's going to be, let's repeat it, S of n is equal to a sub 1 in parentheses 1 minus r raised to n all over 1 minus r. So let's dissect this. First, let's get our a sub 1, which is the first term here. That's obviously 4. Then we got the 1, which is given, minus our ratio. So let's see our common ratio here. So that's going to be, let's try to do 8 divided by 4. Our common ratio is 2 because 8 divided by 4 is 2. 16 divided by 8 is also 2. So that's going to be, r is 2. Then we want our n. N is raised to 15 because we have first 15 terms. Last, let's finish the denominator. 1 minus r. And r is, once again, 2. Let's simplify this. Let's start working with the exponent first. That's 2 raised to 15. 2 raised to 15 is 32,768. So S of n is equal to 4 times 1 minus 32,768 over 1 minus 2. Then let's continue. Let's simplify that, the one in the bracket. 1 minus 4 is times 1 minus 32,768 is negative 32,767. Let's keep going. 1 minus 2 still. So let's finish up the 1 minus 2. So S of n is equal to 4 times negative 32,767 all over negative 1 because 1 minus 2. So we can just simply find S of n is equal to 4 times negative 32,767 4 times negative 32,767 times divided by negative 1. Divided by negative 1. That's equal to 131,068. And there you go. That's a sum of a finite series. But what about an infinite series? What is the fractional form of 0.63 repeating? This repeats indefinitely, the 63. First and foremost, I want you to realize that, first term is obviously 0.63. But you might be wondering, what is the second term? Well, we want to make sure that, let's see. We want to make sure that this statement is true. So, we want to do this. So, 0.60 plus 0 point something is 0.6363. So, obviously, you want to keep these as zeros because they're already 63 over here. Therefore, you don't need any more. And then you can really just copy 63 over here. What you've essentially created is the first and second term of this geometric sequence. So, first term, or a sub 1, is equal to 0.63 because, once again, this is the first one. And then a sub 2 is 0.0063 because, once again, this is the second term we have to add to still make this statement true. So that 63 keeps repeating on forever. You really only need 2 terms to figure this out. So now that we have a sub 1 and a sub 2, we want to find the r. Once again, we just want to do a sub 2 divided by a sub 1. So we do 0.0063 divided by 0.63. That's equal to r being 0.01 or 1 over 100. And now that we have 1 over 100, we can use the infinite. We have the infinite formula here. So it's going to be S of n is equal to a sub 1 over 1 minus r. Am I right? Yes. 1 minus r. So we want to do we want to substitute everything because we already have everything. So we have a sub 1, that's 0.63 over 1 minus 1 over 100. So let's do that. Let's simplify this. So 1 minus 1 over 100 is equal to 0.99. So that's equal to 0.63 over 0.99. But we want to eliminate the decimal point, so we times it by 100. Because as you could see, there's to eliminate the decimal point, we want 1, 2. So ones, tens, hundreds. So S of n is equal to 63 over 99. And that's the answer. So there we go. We have a finite and infinite series solved, which means this is complete. Alright, I'm gonna skip this one for now. I'll save this for last. But we're gonna now solve a problem. What do you call this? A analysis. So let's try this. Heavy rain caused a river to rise. The river rose 3 inches on the first day, and each additional day rose twice as much as the previous day. How much did the river rise in 5 days? So first and foremost, let's analyze for it. The river rose 3 inches on the first day. So that means our first day, or the first term of our sequence, is our 3 right there. Each additional day caused it to rise as twice as much. Twice means double, or 2 times. So therefore, our r is equal to 2. We want to find how much is a sub 5. So do we have everything to find the nth term? Yes, we do. So we have a sub 1 r raised to negative 1. So we got a sub 1 is equal to 3 times r, which is 2 raised to negative 5 minus 1. So that's 4. So therefore, 2 raised to 4, that's going to be 16. And 16 times 3 is 48. So 48 inches is our final answer. And there you go. It's as simple as that. We have solved. This is going to be our sequences. I'll try to make an update video because it's still not out. The presentation is still not out for series. But this is the best we can do for now, and I'll be happy to help on the day of the exam, before the exam itself. Okay, last one. I'm just gonna get my presentation real quick, if I can even find it, and if it's not corrupted. So yeah, I'll send this. Alright, so second to the last topic is the harmonic sequence. It's formed when the terms are reciprocated. They form an arithmetic sequence. So I'll show you what a harmonic sequence looks like. Let's consider this first example. Given the arithmetic sequence, negative 24, negative 28, negative 32, negative 36, negative 40, find its corresponding harmonic sequence of its first 8 terms. So to find the harmonic sequence, you have to be given an arithmetic first, usually. So let's complete the first 8 terms of this, arithmetic sequence. So we got negative 24, negative 28, negative 32, negative 36, and negative 40. So let's find the common difference. So it's just negative 28 minus negative 24. So that's just 4. Right? No, negative 4. Sorry, negative 4. So the common difference is negative 4. So let's keep adding negative 4 here. So that's going to be negative 44, negative 48, and then negative 52. Now we found the first 8 terms of this arithmetic sequence, and all you need to do is reciprocate them. And to reciprocate, once again, you just put 1 over that. So it becomes negative 1 over 24, because that's the reciprocal, negative 1 over 27, negative 1 over 30, negative 1 over 33, negative 1 over 36. Sorry. I was doing by threes. My apologies. I'm tired. Sorry. Negative 28. 1 over negative 32. Negative 1 over 36. Negative 1 over 40. Negative 1 over 44. Negative 1 over 48. Negative 1 over 52. And that's a harmonic sequence, because once you flip them again, it becomes this, which is a arithmetic sequence. So to check, just do this trick, and if it doesn't apply, then it's not harmonic. All right, one last Fibonacci sequence. I can just write this down. How do you spell that? Fibonacci sequence. So it's very simple. It starts off with 2 ones, 1 and 1, and then it continues to add the last 2 terms to make the third term, and so on and so forth. So we do 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 8 is 21, and so on and so forth. Now, what can we do to find, let's say, the nth term? So assuming it's like this, it's like this, right? Let's say you want to find the sum of terms. So it's actually pretty simple. So let's say you want to find the sum of, let's say, usually we start with 1. It depends, but let's exclude the first one here. This trick only usually works, but this is how it's notated. So let's pretend that 1 isn't there. So let's say you want to find the sum of all three of these three terms. All of these terms. So you could simply add them up manually. 5 plus 3 plus 2 plus 1. That's equal to 11. Actually, no. We have to include 1. Sorry. So basically, let's say first these terms. 1 plus 1 plus 2 plus 3 plus 5. That's equal to 12. Simple, right? But let's add 8 into the mix. That then becomes 20. If you haven't noticed by now, to find the sum of the first n terms of a Fibonacci sequence, here's what you need to do. Let's say you want to take the sum of all terms from 5 and below. What you want to do is to hop 2 spaces forward, 13, and then you want to go minus 1. That's 12. So the formula for a Fibonacci sequence, let's say Fibonacci S of n for Fibonacci sequence is equal to f of n plus 2 minus 1. So this is basically saying S of n for Fibonacci sequence is 2 terms ahead minus 1. So let's verify that one more time. Let's try to get all of this one over here. So we're gonna hop 2 terms from 8. So that becomes 13, 21. Then 21 minus 1 is 20. So let's add from this first one to 8. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 5 is 12. And 12 plus 8 is 20. So this trick works for Fibonacci sequence, and it can cut a lot of time. So this is n. And it's pretty self-explanatory. I don't think you just have to get used to it to find the nth term. And there we have it, actually. That wraps it up. It's actually a pretty quick study guide. I've just managed to speedrun that in under an hour. A little bit rushed, but unfortunately I just can't control what they teach us. Raw files of the first page will be sent as well. And yeah, thank you guys so much for watching. It's getting recent typhoons recently, so take care of yourselves, heavy workloads. So take care of yourselves, guys, and I'll see you on the next one. And I might be able to release a special episode on the 16th or 17th of August. So stay tuned for that one. See you guys in the next one, and bye bye.